This will be a follow-up video on algebraic facts, operations that first semester college students should know. So this will be a part 2 follow-up on the last video that I did. So let me just go ahead and go through. I won't discuss this, but these are the items we went over last time. Determine if the following mathematical statements are true or false. So I'll just go through slowly. You can pause when I look at these in more detail. Okay, I have 2 more on this topic here. The true false, number 11. The smallest integer is the number 0. And of course the integers are 0, 1, 2, 3, 4, and so on. -1, -2, -3, -4, and so on. So there is no smallest integer. So that's false. And the last true false on this section, multiplying any integer by 2 will always result in an even integer. This one, of course, is true because that's your definition of an even integer. It can be divided by 2 evenly. So if you multiply it by 2, it's going to be divisible by 2. So that one is true. Okay, then we go to another section here. For this particular video, complete each of the following. Okay, so I'll just give you a few seconds to look at this. Shouldn't take you that long. -2 to the 4th power. 4th power is equal to, and that's -16. Okay, so when you see -2 to the 4th power, it doesn't mean this, okay? It doesn't mean this. The base is not -2. So when you see an exponent here 4, that means the base is taken as a factor 4 times. Now if the base were -2, if it had parentheses like this, then the base is -2. 4 factors of -2, I would give you positive 16. Okay, but the way this is written, this is basically means, okay, negative and then 4 factors of 2. So this is 2 times 2 times 2 times 2, -16. Okay, let's go to the next one. Okay, so in this one here, order of operations. So I have 4 subtract 2 times 6 divided by 3 plus 3 to the 3rd minus 8. So I have the acronym that generally used, PEMDAA. P standing for parentheses, E stands for exponential, M stands for multiplication, D stands for division, and there should be an S here. Okay, so P stands for parentheses, E stands for exponential, M stands for multiplication, D stands for division, A stands for addition, and S stands for subtraction. So basically we always go from left to right. So parentheses always takes preference over the others. Okay, exponential takes preference over multiplication and addition. Multiplication and addition basically are at the same level as are addition and subtraction. Okay, same rank. We go from left to right. Okay, so from left to right we have 4 subtract 2. Okay, so subtraction ranks way at the bottom over here. Okay, so that means multiplication takes the preference. Okay, so here we can say this is going to be 4. Leave the minus there for now, and then it's 2 times 6 is 12 divided by 3. Okay, so again, from left to right, division takes preference. So 12 divided by 3 is 4, so 4 minus 4 gives me 0. So all I have left is 3 to the third. Okay, exponential takes preference over subtraction. So this is 3 to the third is 27 minus 8. That's equal to 19. Okay, so that's your answer. Clear this. Okay, complete the following. If x squared is equal to 25, then x has to be what? So it's basically asking you to solve this very basic quadratic equation. Okay, that should be enough time for you. 5 squared, you say, is 25, so x can be 5. But negative 5 quantity squared is also 25. So this one has two answers. X can be 5 or negative 5. Okay. Cancel this. Go to the next one. Natural log of e to the third. Natural log of e to the third is what number? So basic exponential or problems involving logarithms. Log of an exponential, and keep in mind that it's understood when you have the log of some number and it doesn't have a base here, it's understood to be 10. So if I write log x, that means the log of whatever the x value is, and it's understood to be base 10. When you have ln of a number, it's understood, that's the natural log, it's understood that it's log of x to the exponential e, where e is approximately 2.71. Okay, so in this case, this base right here is e. So natural log of e to the third to base e, well, that has to be 3, because by definition of log, natural log of e to the third to base e is an exponent. What exponent is it? The exponent is that you have to take this base e to get e to the 3. Well, it's 3. Okay, so the answer to that one is 3. Go to the next one. Okay, here we're factoring a difference of 2 cubes. So your formula for the difference of 2 cubes, give you a few seconds to look at the first factor. If you have the difference of 2 cubes, you've already taken out a common factor if possible. The first factor will always be the difference of the cube roots. Okay, the cube root of 8x to the third is 2x. So we're doing a factoring here. And the cube root of 27 is 3. Okay, so that's the first factor. If you have a difference of cubes, the first factor is always the difference of the cube roots of the two terms. Okay, see if you can fit in the second factor. Okay, so it's always the square of whatever this first term is, so the square of that is 4x squared. And change the sign, this is minus, put a plus here. And then it's the product of these two, 2x and 3, that's 6x. And it's always then plus the last number squared. 3 squared is 9. And that's what that factors into. You multiply this times this, 2 factors out, you get this right here. Okay. Just pause the video if I'm going too fast on these. Clear this. Or rewind it. Okay, the next one is the square root of negative 16. Okay, so let me write this way. Let's write that as negative 1 times 16. And then with these properties of radicals, this will be the square root of 16 is equal to 4 times the square root of negative 1. If I break it up into factors. But the square root of negative 1, that's your imaginary unit. So this comes out to 4i. Okay. Just like if I give you the square root of negative 25. Okay. Square root of 25 is 5, and the square root of negative 1, that's what I represents. I is always the imaginary unit, the square root of negative 1. Okay. So this will be 5i. Okay. Clear this. Look at the next one. Here we want to simplify, combine this expression. Okay, so let's just say under the radical here, the 8 can be written as 4 times 2. The 18 can be written as 9 times 2. Okay. So again, we're using the fact that if you have the square root of two numbers, a and b, that breaks down to the square root of a times the square root of b. Okay, so let's see if we can finish that. Okay, so this breaks down then to the square root of 4 is 2. And the square root of 2 is the square root of 2. That's as far as we can go unless we use a calculator. But we're going to leave these in exact form, okay, instead of computing the approximation. And on the next one, the square root of 9 is 3. So that would come outside the radical. And multiply this 2. 3 times 2 is 6. Okay, and then times the square root of 2, and again I leave that as the square root of 2. Square root of 5, I can't do anything with that, so I just leave it the square root of 5. And so this is just like combining x's. I have 2x and 6x, that's 8x. So in this case, see, I have the radical here the same. So that's just like an x and an x, so it's 2 and 6 is 8 times radical 2. And of course the minus is like y, it's not like, we don't have like terms there, so that's as far as I can go, unless I use a calculator to compute this out and get a decimal approximation. Okay. Okay, clear this. And then on the last one that I have for this video is the domain. The domain of the function f of x equal 3 over 3x over x minus 5 is. Okay, so basically the domain has to do with what are the permissible replacements for x. Okay, what values can you replace the x by? And you are allowed to replace it by any number that generates a number. Okay. So you don't want to replace it by something that gives you division by 0, because that's undefined. So in this one, it's pretty straightforward here that if you replace the x by 5, you're going to get 5 times 3 is 15, and the bottom you get 0. 15 divided by 0 is undefined. Okay, so that's your domain. Basically, it's all real numbers except 0. So one way we can do it in set builder notation, we can say the domain is set of all x such that x does not equal the 5. In other words, you can replace the x by any number except 5, and you're going to generate an actual number. Okay, so that's one way we can write it in set notation. We can also just say the domain is all numbers except 5. We can also say give the answer in interval notation, but this will suffice for this particular video. And I'll follow up with at least one more video on this series. So thanks for watching, and we'll see you next time.